So welcome everybody to this presentation titled How Sleuth Bravely Cracked the Case of Too Much to Code. We're really happy that you're here, even though there are really interesting presentations happening in the meantime. So we have quite a few things to show. So we're going to start by talking about ourselves. Why not?
Yeah, well, we both work in the same team, both at Pivotal and also for open source. I spend most of my time on distributed tracing, which we'll get into, and Zipkin, the system you may have heard of.
And my name is Marcin Grzejszczak. I work also on the SpringOne team, mostly focusing on Sleuth contract and deployment pipelines. My Twitter handle is @Grzejszczak, and you can find it also on toomuchcoding.com, which is my blog. Now, what's on the agenda? We have quite a few things. So for those who don't know what Sleuth is, and there's quite a few of those, we're going to shortly recap what that is. We're going to mention how exactly it works, like internally. Then Adrian's going to say a few words about what Brave is and how Brave works. And then it's going to be back to me about what the problem with Sleuth was, because you might not even know that there was a problem. And we're going to show you how we changed Sleuth to work with Brave. And then Adrian's going to talk to you about what has been added, like out of the box, just by adding Brave to the class path. And then demo and the roadmap. Okay, so what is Sleuth? So Spring Cloud Sleuth is a, well, of course, open source project, which is, let's say, doing the distributed tracing in the Spring Cloud portfolio. It borrows a lot from the Dapper paper for Zipkin and htrace. And the first release happened in 2016 in May. So it's not that old, but not that young. It's of relative age. So what does it do? It records timing information. So it knows about the time that different operations took. Why do you need those? In order to do latency analysis. So how do you do those? You add certain IDs, a trace ID and a span ID. So trace ID is let's say if you have a, let's say, business operation that involves a couple of services, so the whole flow within this system for a single business operation is called a trace. Let's say parts of that trace are formed by spans. So multiple operations wrapped in spans form a single trace. So Sleuth instruments common ingress and egress points from Spring applications. So it knows how to instrument, HTTP clients, messaging clients, different sort of things in order to propagate the tracing context. Speaking of which, it knows how to actually continue a trace, right? So if you get proper headers in a message or like an HTTP call or a messaging message, so to say, Sleuth knows how to continue the trace, how to extract the headers and how to create spans out of it in a trace. It knows how to also propagate a context. It's also known as baggage. So it's a key value pair that once set within a life of a trace will be available at every single service afterwards, right? So you can set a key value at the beginning of like in the first service, and then the last service can actually retrieve that value like from the store, from the baggage. It knows how to also work with the annotation-based computing, so to say. So you can, by using annotation, create and continue spans and create logs and tags. Tags are, let's say, a certain annotation that, like a key value pair, again, these are tags. And logs are timestamped events. So something happened in time with certain name, it's called a log. And Sleuth can send, let's say, those spans for proper sketching in the UI and proper processing to Zipkin. It can be done via HTTP or messaging. So let's say that we have 4 services. A request comes in. There is no trace or span information. So what Sleuth does, it creates a new trace. Let's call it X. Actually, it's a number. And a span ID. Let's call it A. So now when service 1 calls service 2, let's say it also creates some sort of a baggage. So a new span is created, but the same trace is there, right? You can see trace ID equal to X. So we can see that on the client side, we've managed to send a request. On the server side, we've managed to receive it. So in the RPC situation, you have 4, let's say, pieces of this communication. Client send and server received are half of it. You're going to see the other half in a second. So let's say we created another span, span C, and then you can see that we all the time propagate the baggage. One set at the beginning is going to be propagated further on. So we have the same situation, now we go back. So in the RPC situation, we have client sent, server received. Then we have server sent and client received. So those 4, let's say, events have to take place in order to have the full cycle and to know what kind of latency was on the network on the request and response side. Let's say the same thing happens here, and when we start going back, we have again server sent, client received, and then we send back the response. So this is the full cycle, a single trace, multiple spans. And this is the parent-child relationship. So the first span did not have a parent, then the next one, like span with ID B, has the parent with ID A, CB, and you can see that you can have multiple children for a single parent. So how does Sleuth actually work? It's very easy. You add a dependency, and that dependency, thanks to the auto configuration from Spring Boot, adds instrumentation, right? So you can add one of the 2 dependencies, either it's start or Sleuth. If you want to just have log correlation, and you're not using Zipkin, for example, but you're using, I don't know, Kibana or whatever other stack you have to analyze the logs and to correlate the logs. Or you start Zipkin to send the spans to Zipkin for processing. You have to set up Sleuth. For example, you have to set the probability. So until Sleuth 2.0, it was called percentage, but it turned out that it's actually not a percentage. That's why we've renamed it to probability, because that's what it is. So now you have to define the probability. You have to provide the baggage propagation keys starting from 2.0, meaning it has to be explicit. If you don't provide those whitelisted propagation or baggage keys, they will not be propagated. And the new feature quite recently added is you can whitelist certain pieces of baggage that should automatically be put in MDC in the logging context. And then time to observe. So your apps are running. The tracing context is propagated, logs are correlated, and once you send the spans to Zipkin or Zipkin-compatible servers, what happens is you could analyze the latency, do the latency analysis. Sleuth for log correlation, Zipkin for sending to Zipkin, and there was the legacy thing, which is deleted since 2.0, Spring Cloud Stream. So you could have a stream server, and you could have a stream client to send out spans. Now it's completely removed. In Edgeware, I guess it was deprecated. You add the BOM, Spring Cloud BOM. For example, you add the Finchley release, and then you add Spring Cloud Starter Zipkin, and that's everything you have to do. And then you check out Zipkin, and you see that there are 4 services talking to each other. For those who don't know, I can't really point to it, that doesn't matter. So the width of the arrow, the wider the arrow, the more communication happened between those services. And if you click on a service, you can actually see what kind of communication took place, who called who and how many times. And this is how let's say, waterfall graph looks like in Zipkin of which app called which, how much time it took. This is let's say, already the Brave-like nomenclature of spans. So name of the method and the URL, so get start, for example. The white dot is the event. And if we click on one of the spans, we'll see at the top, we'll see which services took place in the communication, so service 1, service 2. We have our annotation, so we know exactly when we send the request, when the server started processing it, when the processing finished, and when the response got received. Key value are tags, and to the bottom, if you click more info in Zipkin, you can see trace ID, span ID, and parent ID. So what is this tracer, right? Because you have to somehow arrange those spans, start the span, put it in context, continue, add a tag. So how can you do it? So you can do it via a tracer. So with a tracer, you can create a root span, you can create children of the root span. So it's like a core component of, as far as distributed tracing is concerned. So this is how Sleuth used to work, right? You should be familiar with that. Who's seen something like this? Okay. You've seen it? Good. So in this tracer creates span, it creates a span with a given name. What is important is this span is started and put in the context. So it's available, it's in the thread local, it's there. There's no other way to create a span, let's say in an easy way, other than this, right? So it's put already in the thread local, and we had this bizarre API that you could have added the tag via the tracer, but you were adding an event on the span, right? So that's kind of bizarre. And once you're done, if you wanted to send the span out to Zipkin, you needed to close it via the tracer. So from the internal perspective of Sleuth, when we had Sleuth core, the definition of the span and the logic of a tracer went out from Sleuth. We wrote it in Sleuth, we maintained it, we added features to it. So it was inside Sleuth. And we had a Zipkin span reported in Sleuth that used Zipkin reporter library coming from Zipkin, having different ways of sending out spans, including the async reporter and the sender classes. So what were the conventions using the Spring Cloud Sleuth tracer? There was this problem with the creation of the span and setting it in context. So created span was immediately started, right? So you couldn't actually, another thing is that you couldn't actually tweak the duration of a span. There are some cases where you want to do that. That was impossible. And we always put the span in the current context, which was quite problematic. Due to the fact that there was no separation of putting the span in the context and creating it. Especially with Reactor, we had quite a few problems. Another problem was that something decision was taken upon span creation. It was very, very difficult to take the sampling decision basing on some input, like, for example, HTTP request, which was absolutely, I think, most common asked for feature in Sleuth, right? I have a special request, and for example, if I have my custom header, I don't want to sample. So that was close to impossible to be done. Since most of the naming and concepts came from the cooperation of mine and Adrian's, the naming of, let's say, pieces of the tracer of span was almost identical as the one in Brave. So now, Adrian, can you tell us what Brave is actually? Because I've mentioned it a couple of times. So can you introduce Brave?
First, what is Sleuth?
Sleuth is a detective.
Okay, quid pro quo. I'll tell you what Brave is. So Brave is a library that was created by the Zipkin ecosystem. I think I may have slides. But the original project was made by a guy, Christoph, who was working at TomTom, and they were trying to do their figure out where the requests were going. And he's originally from Belgium, and there's some playing with names that somehow it went from the word Zipkin back to Brave, and from some linguistic tricks. And that actually continued on. There's actually an Elixir project, Erlang project that's named Tapper, which followed this sort of name games to try to link them together by definitions. So Brave is sort of named because of some nuance of languages. But really it's a library to do the tracing aspect. When Marcin was talking about tracer, that's what this one focuses on. And so it was released in 2013, which is pretty old in distributed tracing library land. A lot of folks are hearing about it recently, about distributed tracing, because there's a lot more products out there. There's a lot more demand because of microservices, and things are getting a little bit difficult to figure out where things are going. But Twitter itself was open source Zipkin in 2012. This was the first Java library So it's had a long history. It's like API version, we're on like version 5. So it's a fairly polished thing. What's notable about it is, especially in the case of frameworks and low-level code, you have to be very careful about dependencies so that you don't introduce something that's going to conflict with your applications. Brave has no external dependencies, not even a logging library. And so it's very easy to slip into environments. It's a very small, like 150K jar. Some tracing libraries are like 4 or 5 megabytes. And so it also works in Android. So there's a lot of dependency-related care and rigor that's placed, and that's again a function of experience. If you're doing this for several years, then you'll get people complaining about these things if you don't address them in the beginning. And on top of the tracer library, there's a layer of components to sort of make things traceable. That's called instrumentation. So we'll go over some of the ones in the catalog, but like you can imagine like common things like your database connections and servlet frameworks and things. They'll have some essentially plugins to instrument those, make those things visible inside your trace. When Marcin was talking about like these trace diagrams, there's always a place where you have like some unallocated time, and instrumentation is the thing where you get to see a blob about whatever was happening there. So like as your requests go at a service level, you might only see a certain part of your service graph because only those things have tracing enabled. But even inside of a process, you may only have certain components that have instrumentation. And so these are ways to get more granularity. So you can see details, like the Spring controller if you're writing in Spring. And the one thing that we found over time is that tracing is actually about your whole architecture, not just your shiny new things. And so there's considerable deployments of technology. There are like Spring 2.5 MVC apps. People are using XML config. They're not using Spring at all. And that's another thing that Brave focuses on. It requires JRE 6. That is a minimum requirement, but we do like ship in Spring Bean support and other ways to allow you to kind of weave in all of your apps, or as many as possible, not just the shiny ones. And then when you do have things like SLF4j or Log4j or Log4j2, there are plugins so that, for example, the trace IDs will get into your log statements, which is really, really handy. It's the way that you transition between these tools. So for example, if somebody has a stack trace, then hopefully there'll be a context property in that which you can then jump into the trace screen and vice versa. So it's a really important thing to kind of like fit into other environments. Zipkin is not a replacement for Elasticsearch. It actually can be, it can store stuff in Elasticsearch, but it's not a replacement for logging or metrics. It actually is a thing to add into addition to your tools and try to be kind of a lightweight helping hand there. And like Marcin said, we have this lingo in tracing land called span, which is basically a label of an operation, like a controller that's doing whatever function, and then the time it took with some tags and things. So that's what a span is, and they usually are reported in JSON, but it can be also reported in protobuf or other formats. And so it's in the way this is about primarily a conversation about how things changed in context of Spring Boot. And so the way that things usually work in Spring Boot is that you would add a dependency to have additional features available to you. Whether they'll be installed or not is this auto configuration, so like whether properties or certain other dependencies are there. So having Brave a part of an application would be in that realm. So like versions are aligned with this thing called BOM or Bill of Materials. And then you could cherry pick the things that you need, like if you're using OKHTTP or RPC framework or something like that. And If you were working in a pre-Sleuth world, what would happen is that you would configure the components that you need, like the tracing component that tells it what the sample rates are and things like that, and then go through the process of like adding interceptors to such. So there is some commonality with Spring Boot, but because it didn't have a auto configuration thing, you would have to perform some of these steps on your own. But at the end of the day, once you get these things set up, you wouldn't necessarily even know that one trace was created by Sleuth or one trace was created by Brave, because the whole point of a services architecture is that it kind of looks the same at a service abstraction, and you don't have to know what language everything's written in. So definitely you could have these things working together without any cooperation. So here's an example of just putting in a bunch of things if you're using Spring and Rabbit and Kafka and HTTP client at the same time, which is increasingly common. You just plop all those things in there, and then that would avail some of those components. So using the same example as Marcin had earlier, if you had like a custom span to do like a tax collection, then the API is a little bit the same, but there's some differences. First off, we're using version 5 of Brave, but starting with version 4, which was the first big redo we did about a year and a half ago, was that there's a primary thing called a span, which you get, and that represents the whatever operation that's taking place. So for example, like calculating tax, and you can defer whether it starts or like all these things. But one thing we learned, and this was actually a lesson we learned from Google themselves, which is kind of a nice thing, because like Google made Dapper, and then we were able to collaborate again some years later. But what we found was that like there's a common pattern where people were having trouble with like thread locals and asynchronous programming. Like oftentimes your command doesn't actually always start and stop on the same thread. And so when you want something to be visible, you actually have to tease these things apart. So for example, you may have a callback here is where operation started, but then it goes 3 other places before it finishes. And so you don't necessarily want to assume that the same thread is doing all those things. And so that's why we have this scoping operation. And so you have in this case, we're showing an API which allows you to decouple those things. In practice, we have a different one that's simpler for synchronous code, but it's important to show that that can be teased apart. And we don't expect people to do this manual tracing thing. It's mainly just to show how the libraries work. Like obviously, if you're using a Spring type approach, you'd probably use like an annotation and just say at time, trace this. But at the end of the day, this is how it works under the covers. And so usually the annotate thing is again events. So this is sort of like cache miss or any other type of like retry occurred, not like Mary had a little lamb. So this is not for full text search and replacement for log4j or anything. This is mainly just to say that there's a notable moment inside of the span of this operation where some state event occurred, and that could be helpful for you troubleshooting. And so that's what they're used for. They're actually rarely used. And the architecture here, from a library point of view, so I mean, like what Marcin said is true. Like a lot of the libraries, whether they're like Nike's or anybody else's, doesn't really matter. Most of them reuse this reporter component because that's the one that says, okay, here's how you do HTTP, here's how you do Kafka, and all these other like JSON encoding and blah blah blah. So we would use this. We had used the same library as Sleuth was using for that part. But we had different APIs for some of these features that over the years we realized needed to be separate. So for example, propagation, which is the idea of taking that context and moving it, as it comes from like headers, whether they're messaging or HTTP, through the process as it hops across threads, and then of course downstream to wherever that particular request goes. How to plug in the idea of what's current. So for example, most typically people use a Java thread local to represent what is current. But there are different libraries that have different mechanisms that might be more efficient than a thread local, so that's all pluggable. And you saw the span API. We also have the scoped span one, which is kind of like a 2-for-1 for simple synchronous code, which basically looks like that, but you don't have this with span and scope thing because it just does that at the same time. And so yeah, that's how the library works. And so that simplified one is actually pretty recent, and it was mainly because we saw some performance opportunities. Another thing that happens over the years is that people start asking that scary question to all performance management company, which is that, what is the overhead? And it's like 1%. And of course that's a terrible answer, but it's one everybody gives. It's like 1% of what? A million? So there's some types of coding which require more overhead to track than others, right? So if you do straight up synchronous code, you don't need to worry about threads hopping, you don't need to worry about synchronization inside of the API. So we had some advantages from a performance standpoint that we could optimize for. But also, there are still many cases in our code where we have synchronous code out there. It's just like this method starts and stops. It doesn't hop any threads. So it's simpler to keep an API like that around. So that was kind of a handy thing we learned, which is that, yeah, you want power, but you also want simplicity. And by the way, simplicity can also give you some performance advantages. So, and also, we found that, and this was an interesting one, just because we have so many sites that are using Zipkin. One of the sites is Tyro, who's a bank in Australia, and they noticed that, most of the time, people don't need to muck with the life cycle. Like starting and stopping things. They just want to add a lookup key. Like I want my customer ID to be visible in whatever is going on right now so I can look it up later by customer ID. And so they don't really want the surface area of like an entire tracing API in their business code. They don't want the liability of that. They don't want to worry about API drift or anything else like that. And so if you're just doing things like I want to rename whatever the current operation is, or I want to add a tag with my customer number, then you could use a much simpler API, which has a whole bunch of guards around it called Span Customizer to do those simple things. So basically, we have 3 ways of customizing data, which is just because of site feedback. And inside the tracer, like what Marcin said is that in Sleuth, there was a convention of sampling, which means deciding whether or not you are going to trace this specific operation implicitly as a process of starting one. And we do have the ability in Brave to do that, but definitely there's some advanced options available. So if you do nothing else, whatever you set your rate is or your probability is, then that'll just carry through. And importantly, it's made at the beginning and it's carried through consistently, which was another lesson learned. So for example, the same folks that made some of these libraries, they went to another company and they realized, well, we found that if people keep choosing whether or not to keep data as a request goes around the tree, when it comes to troubleshooting, people don't know what happened because they only have this piece of data and that piece of data, and maybe it's put in the wrong spot because not all the data is there. And so you're actually confusing people at the very worst time to confuse them, which is when they're actually trying to troubleshoot something. So that's a very explicit, important decision to make, especially when starting to keep things as coherent as possible. And the easiest way is that if you're deciding how much data to keep, do it at the very beginning. And so that's the default there. So we have plugins because, for example, Amazon, you may have heard about this X-ray service. So Amazon Web Services has the ability to do distributed tracing. I think even recently their API gateway products allow to do tracing that starts through there. Their Lambdas definitely do. And so we have the ability to allow you to use their header format. There's an Amazon Trace ID, and even ship data straight to Amazon without touching any server on your infrastructure. So these things are, again, natural progressions that you get based on what people are doing with their code. And of course, the same thing exists for Google Cloud and whatnot. And then the other thing was we found that if you just if you're trying to like make things visible, that's nice. It's nice to like see that there was Netty here and you know, and servlet here, and then maybe you have some code that wasn't even Spring. But if you don't have consistent data, then it's really not very helpful to anyone. So for example, if you're if you, in one side, you'll take the entire HTTP URL, and then the other one you put just the path, and you try to do some lookups and things like that, it just creates some friction that's not necessary. So we have an HTTP model that's used for all of our HTTP instrumentation. Doesn't matter if it's Ratpack or if it's like, you know, whatever, even Play. You can have an ability to give the exact same object to configure like what data is captured and how that looks. And so that's helpful for two reasons. One is the consistency, but the other is that there's a linear relationship between how much data that you collect and how much it costs you. Like sometimes it sounds nice. It's like, well, let's keep stack traces and let's keep queries and let's keep all this. But then all of that ends up just racking up your bill, whether it's like a cloud bill or whether it's like the size of data in your Elasticsearch. And because most people only keep data for a few days anyway, you know, you can choose like, okay, I'm rolling out a services infrastructure. Maybe I start with 20 or 50 services, but like if I get to 200, these things, or 800, however many, these things start to matter, you know, because you know, it's just literally cost. So you can kind of decide what to do. By default, it's fairly parsimonious. Like there's not a lot of data, just like key things like HTTP methods and things collected. We've learned that most of the sites, they like the idea to do like napkin math. Like, okay, I have this many requests per second, how much is it going to cost me? And so we try to keep the default size of the spans in like the few hundred bytes range. And as soon as you get past like a kilobyte, like we start saying like maybe you should choose to record less. But by default, it doesn't tend to record that much. And that was actually a lesson learned from Twitter. Like a lot of infrastructure is much easier to reason with if you have some rate per second and some kind of idea how big that is. So like if you have 1.5 million spans per second, that is helpful for you if you know that one of them isn't like 5 megabytes and one is 10. So it's a nice thing from a systems and operation point of view to have in mind. And a HTTP model is one of the tools that we have to simplify that. So that's that. That's a fire hose of information. So if you have questions, obviously we'll come back to it. But moving right along, what was the problem anyway?
Let's check it out, what the problem was. Yeah, so SpringOne Sleuth evolved, right? We did quite a few things. And then it turned out that this fact that we are putting the context, like spans to the context eagerly, like, is not a good idea because of various reasons, one of which is Project Reactor, right? So like Adrian said, the fact that in Brave there is this option of splitting the fact that, you know, you create a span and you put in the thread local, that became an option that we wanted to consider using, because with Reactor, like it's extremely problematic because the reactive programming model is really contrary to the concept of a thread local, right? So that was problematic.
Well, you say right, but
Come again?
like, so how many times might like I have a task to do, like how many times might it switch threads in Reactor?
The answer is it depends. So you actually never know, and that's like the instrumentation code of Sleuth and Reactor. We can take it offline, but it's very interesting, so to say. Another problem we had was that instrumentation work was duplicated. So, for example, there was a feature done in Brave, and I had to write exactly the same feature in Sleuth. And I couldn't copy-paste, because the concepts were completely different, right? Even though the naming was similar, but the fact that the context setup was different made my life very miserable. Yeah, so we had to write it twice. And we really, really wanted to involve the Brave community because, like Adrian said, Brave was an older project. There were more people using it. and also non-Spring users, right? And they were interested in helping us in Sleuth. But for some people, it was really impossible because they were helping in Brave, and they would have to copy, create things from scratch in Sleuth. So we didn't want that. So how do we change Sleuth with Brave? So there was this commit happening on the 19th of January, which was a very good commit, because I've added 8,000 lines of code, and I'm not paid by the line, unfortunately. Or actually, fortunately, because I deleted 18,000 lines of code. So all in all, minus 10,000 lines of code. And you can see all those fixes. So out of the box, we fixed 7 issues, just like that. It took some time. It was a long-lived branch. But it turned out that due to the fact that with Adrian we cooperated from the very beginning, a lot of concepts were very, very similar, right? The biggest problem was, of course, how to tackle this, because internally, like the whole internals were ripped off. We had this, so span and tracer were defined in Sleuth, and then we had to migrate to this. So no longer was span defined in Sleuth. We had to pick it from Brave. The tracer logic, no longer was it there in Sleuth. We had to take it from Brave. So not only didn't compile, but it also involved a lot of, let's say, work around the fact that you have this lazy, let's say, setting up in context or explicit one. And the thing that I've made most bugs, like when I was doing this migration, is that you have to explicitly start the span. And there were issues where it was like people were saying that span has no time information in Zipkin. And that's because I've forgotten to press write dot start on a span. So if you migrate right now, or if you've migrated, remember about explicitly starting the span.
Or just use a scope span, because that starts by...
Yeah, use the scope span. But that's quite fresh, right? So we had this, and now we have this. So when we create a span, it's not started, and it's not in scope. We put it in the scope here, and we start it here, right? So that's the main difference. As far as tags are concerned, you put a tag directly on the span right now. You don't do it via the tracer. This thing changed the least. So there was log event, now it's annotate. And yeah, we finished the span to send it to Zipkin, and we used to close the span explicitly via the tracer. So now it looks like this. So it's almost the same, but from the library perspective, it was quite a big work, and it gave us a lot of opportunities. So what else did we change? Percentage to probability, that's the most important thing. We had span injector and extractor, so the interfaces to allow you to, let's say, modify the behavior of how you take the tracing headers out and you put them in. So you have to use the Brave customization options to do that, which are far more powerful. You have to whitelist baggage. So if you have baggage, right now you have to tell us what are the names of keys. Otherwise, it's not going to be proper.
An example, if you had a customer ID that you wanted to have in all of your traces, then you could just put that in this, and then this will carry it around. And that would be an example of one thing. Yeah.
As far as, for example, asynchronous template is no longer a bean. You have to define it out of the box. So these are breaking changes, unfortunately. Trace filter. There's no more trace filter. So trace filter, due to the fact that we had this eager putting of span in thread local, it turned out that trace filter started to become a monster because there was hopping back and forth, for example, from the trace filter to the error controller and back, and sometimes you went again to the filter or somewhere else, and then again to the filter, and sometimes you wanted to do something, and other times you didn't. So with migrating to Brave, I did what I love the best. I delegated the problem to Brave. I no longer had to write it myself. And it was due to the fact how Brave is working internally, it was much easier to do it. This is interesting. So the client receive, client send server receive logs are no longer there. because you are using Zipkin v2. So it's the span.kind. So the kind object on the span tells you how to, together with the information about timestamp, duration, and remote endpoint, tell you what kind of communication we're talking about. So we have client, server, producer, and consumer. Producer and consumer for the messaging piece. And you can check out the Spring Cloud Sleuth 2.0 migration guide with a wiki page on GitHub to see all the, let's say, pieces you have to, all the things you have to do to migrate from 1.3 to 2.0. So Adrian, what was added to Sleuth thanks to Brave? Can you tell us?
Well, actually, it's an interesting thing because basically what Sleuth becomes is more centric on what it does best, which is auto-configuration. So if you think about it, a lot of the Spring Cloud projects are adding value to existing things, right? I mean, it's how do you make streaming easier, or how do you make this easier? So Sleuth is now, while there is some like instrumentation that currently lives inside of Sleuth, what we get the ability to is that if somebody has code that they're using elsewhere that's not prepackaged in some distribution, you can just add it in, and so that's because they use the same components. And so we have some things that are library level, and then we have some things that are like instrumentation. One thing is a dynamic sampler. So we have the ability for people to control sampling, meaning that like how many traces will happen and how they occur. So for example, is it based on HTTP requests, or is it based on annotations or other things like that? And so there's some internals there. We have had an interesting experiences with some of the Zipkin folks. Is that some of them started and they're like, well, I'm running my own Elasticsearch. And then they use hosted Elasticsearch. They're like, well, maybe I just want to use X-ray. And so like some people are like moving around and just deciding, because like, for example, if you only have a few services, would you actually want to run a service architecture just for tracing? So like we have things like Amazon X-ray integration, which is important to give choice as far as like, how much control do you want over your infrastructure. Yeah, we have some things that are less common, but might become more common in Spring Boot. So for example, does anyone here know about Dubbo? If I were asking that question in China, everybody's hand would go up. So Dubbo is like a gRPC for, and that was made, it's an Apache project, and it was originally made by Alibaba. And it's super popular in China. And so we have like a lot of folks in China that are now contributing to Spring Boot, and so we have the ability to obviously like plug in this framework, but other frameworks that you might be using that may not have a Spring Cloud starter yet, or things like that. You can drop in support for that. Obviously, gRPC is a big deal for some people. So we've had gRPC for a long time. In the Brave project, and like for example, our integration works all the way back to gRPC 1.3, and we test all the spreads. So that like, if you didn't know, like I don't know, they're up to like 1.20 or something. I don't know. And then of course we have some decorators for the common things you'd expect, and and most interestingly and most recently is the JMS, because JMS is quite well deployed in a lot of enterprises, but it's also quite quirky with regards to its limitations. Like, so for example, JMS doesn't like hyphens and things like that and headers. And so we actually had to do a heck of a lot of work to make this very seamless within JMS infrastructure. Also Kafka, like, there's a huge amount of interest and deployments out there with various Kafka components. And so not everybody is using some of the Spring abstractions. They might have their own, they may still be using Spring Boot, but they might be using their own Kafka clients. And so we have the ability to choose sort of your abstraction there. So that's really handy. And it goes on, expected things like MySQL. Yes, we have people who are writing their own Netty code, like that happens. And then not many people know about this thing, P6 Spy, But if you're using JDBC, there's a way to sort of like intercept all your JDBC commands, and this is a way to like hook into that. So for example, sometimes we have people asking like, well, what about Oracle? And it's like, sure, that's actually a very, very valid question, but like a lot of open source projects don't have the ability or the licensing for all database projects. Sometimes you can't link to the code, sometimes you can, and getting volunteer to do things for those things is a little bit less likely. So JDBC to the rescue, right? So even if you don't have raw driver support for tracing, at least you can use a JDBC abstraction and get some metadata around things like that. So that's really handy, and P6Spy is a nice library. And of course, there's other folks using different frameworks that have all these things. It's important to note that our culture inside of Zipkin, and especially the Brave project, is we have the rule of 3, which was like from the Coding Horror blog, which is like the idea that if you can't convince 2 other folks that something is useful, then maybe you shouldn't do it. And so all of the instrumentation have at least 3 customer sites that were interested in this particular framework. So we're a little bit, it sounds like that's not very many. And it isn't, but like a lot of times open source projects accept code at the first light, and that can create a substantial tech debt over time. So we try to do our best to culture a culture that is responsible and puts things in after they're in well demand. So there will be things that you don't see here, but they're actually available from folks either on their private repositories or ecosystem things as well. And I don't know, we're ready for the demo?
We'll see about that.
Okay.
So, who's not sleeping? Okay, nobody. There are some people not sleeping. Let's code some stuff. So, who knows this page? Who knows this page? Who has this page as a home page? Oh, there's one guy. Good. Yeah, except for Josh. So we're going to do, because everybody does reactive, we're going to do reactive as well. Why not? So we're going to add the reactive web and the Zipkin client. By the way, do I have the Zipkin thing running? Yes, I do. That's good. So I have those 4 apps running. Actually, I should have not. I'm going to just show you like this. So we have the 4 services already running, service 1, 2, 3, and 4. And I'm going to write the S1P service, which is going to call the service 1. Yeah, so let me generate this. Let me call it S1P, and let's generate the project. Okay, I'm here. Can you see the font? Is it good? Okay. Unzip. And yeah, like a mouse. And let's open it. So we're opening the project. You can see that we're using boot 205 with Finch DSR1. We have the starter web flux and starter Zipkin. It's as simple as that. So let's see what we have here. Of course, it's not the case that you have normally. This time, I'm not going to write a test. You always write a test. Actually, I'm pretty sure you never write a single line of production code without writing a test. That's good. I'm not going to do it because it's a demo. So I'm going to write a REST controller, class S1P controller, and I'm going to have a get mapping over here. So if we send a request to S1P, we should return a mono of string, because why not? Now, we need to send the request, so how can we do it? We can use the web client interface to do it. So let's inject it via constructor, of course. And now we should define it as a bean. So let's add a bean of web client type. And we need to use the builder. And we're going to say that the base URL is localhost 9801, because we have microservices, so I have hard-coded the port. So right now, we're going to return this web client get to URI start. And then we're going to do exchange flat map response is going to be body to mono of type string. Okay. And on success, what we want to do is we want to log something out. So I'm going to log out via a logger. Log logger factory S1P controller. So on success, I'm going to log something out. I'm going to say, well, response, and I'm going to put out the response to the body. Now, we can also put a log over here. Going to say before. So is it like done? No, really, because we have to provide the name of the app. So Spring application name. It's going to be S1P and probability. Yeah, probability 10. Right. If you wanted to do it via a bean, it changed because no longer do we have the Sleuth sampler. We have a Brave sampler. So we would do a bean sampler, and we would do return sampler, always sample, right? But we're going to use the probability-based one. So if I didn't do anything stupid, which for sure I did, I'm going to run this.
Well, where's the tracing code?
That's the thing, we don't need one. We don't need the tracer, because nothing here has to be explicit. Everything is done under the hood, implicitly. Let's check out the logs, nothing really there. And now I'm going to use, so if there's anything except for the coffee and cookies that you should take out of this presentation or this conference, is this HTTP thing. Who knows the HTTP CLI? Okay, there are quite a few people. So you can do quite a few things, because by writing this, HTTP colon 8080, I will send a curl request, so to say, a HTTP request to localhost 8080 to S1P endpoint. Good, something works, so we have a response. If we check out the logs, we'll see that in the before, we already have a trace ID. So for those who don't know, SpringOne Sleuth, let's say, modifies your logging pattern to include the name of the app, the trace ID, the span ID, and whether we should send the span to Zipkin or not. So in the before section, we already have the log, and then we have response, which also has the span ID. So if we go to Zipkin, if we do find trace, we find our trace. Awesome. So we have get to S1P. So our controller was instrumented. We know that it was the S1P controller with a method S1P. If we check out the dependencies, we see a nice graph having more things there. Okay. But you would say, I never do such things in the controller. I have to create a separate class to call the service. So fair enough, service1 client. We're going to copy most of this code, because this is how we roll. Copy, paste. Sweet. So now we're going to say, I want to create a new span. So we're going to say new span, and let's call it, for example, calling service 1. Okay, so over here in the controller, we will inject service1 client. There you go, there you go, there you go. Okay, and we're going to call S1P. So it's running again. Let's check out the logs. It's really fast. I mean, not my laptop, because my laptop is absolutely terrible. Okay, so we run this again. Great. So now we can see that we have the first before. Actually, the logging is terrible because I didn't change the name over here. So the first log has the root span, the root span ID, so the equal to trace ID. Then, via the new span annotation, we've managed to create a new span. So if you have been using Sleuth until now via annotations, your life will be less miserable than if you have using tracer explicitly when you migrate to 2.0. So let's check out Zipkin. Okay, we have 2. Let's check this out. Sweet. So right now we have calling service 1. It's over here. You can see that, calling service 1. So now, let's play around with customization, because let's say we want to add some tags. Actually, we would like to rename a span. Oh, we didn't say about this. In Sleuth, there was no option of renaming a span. Once name was given, no way to change it. So how about we want to change the name? So we can add span customizer as a dependency. And what we'll do is, we're going to do, let's say, before over here. Well, let's add here. We're going to change the name to hacked. We're going to add tag conference and S1P. And we're going to add an annotation, whatever, hello. And let's run it again. So what I expect to happen is that I'm going to get a new name. I'm going to get a tag and a log. Okay, let's check out what we have here. News first. Oh, there you go. Something got hacked. And if we zoom out, we'll see that we have a conference S1P and annotation hello. Right? So you can use the span customizer in a nice way to actually do this kind of customization of a span. So that was a good name, span customizer. Now, to show exactly like how this insertion of context looks like, what we can do is this. We're going to leave the before log over here, and now we will create a span manually. So we're going to do private final span tracer. We're asking for tracer, there you go. So this tracer comes from Brave because there's no longer a Sleuth tracer. So what we do is tracer next span name, and let's call it my span. And now we're going to do two things. First is we're going to create this span, and I'm going to create another log over here. So after creating a span, and I'm going to put I'm going to do a try with resources, span in scope, and via the tracer, I will put the span in scope. And I deliberately won't start it to show you what the problem will be. And over here, I'm going to do span finish. So I will put a log over here, and I'm going to do hello, and let's see what's going to happen. So what I'm expecting is, since in Brave you have the separation of creating of a span and putting it in scope, so it should behave differently than Sleuth would behave. Let's check it out. So we have before, so it's this fellow over here. So we have the span equal to trace, right? Now we have, after creating a span, it didn't move a muscle, right? No span in scope. Now in hello, you see that there is a new ID. It's over here. So over here, span is put into the thread local. And now if we go to Sleuth, to Zipkin, if we go to the newest first, and we define traces, we'll see that my span is very sad because it has no duration. It's so slim. So right now what I have to do is put this start thing.
I'm going to take over. Now I'm going to do something crazy. Start, scoped, span. Bam. Blam.
We'll see about that. So, you have to remember either to use the scope span, and then you don't have to remember about anything, or you have to explicitly start a span.
And the main idea is that it's very rare that you're going to get into a situation that you need to worry about manually doing things that have to hop threads. So if you find yourself in a situation where you need to do that, then yeah, you'd use the advanced API. And so the simple one avoids mistakes without removing the one that you can use to do the crazy stuff. So that's the general guidance. And more general than that would be, don't code this. use the annotation.
Use the annotation. But like for you to understand how it internally works, now you can see that the span is there, and the duration should be less miserable. Let's check it out. Use first. It's still miserable, but it works. Okay, let's sum it up, I guess. So what's on the roadmap?
So, let's see, did I put anything on here? So, let me use this instead. One of the things that's extremely high demand from folks is that they want Sleuth, Brave, or somebody to take control over correlation in general. So you saw us put trace IDs in the logs, and definitely people have things like SLF and MDC, which are things to like put things into your log files. But folks want to have things like the service name and the span name or any other thing, in their logs. And so there's some, I would say, medium-term work that will land to basically give an API to control that data that's getting into the log files. We have something that will definitely be in the final release of 2.1, which will allow you to adjust any span, not just messaging spans. But we will probably have in the near term a messaging span adapter similar that we have for HTTP, which means that it doesn't matter if you're using Kafka directly or RabbitMQ directly or JDBC, that the data will look the same if you're crossing certain boundaries, and plugins. Because one thing, folks here, do they know what micrometer is? There's a few, but micrometer is basically a metrics library, so you can time things, right? So there are places in your code that may not have timings. You might have like a new span annotation on them, or you might not have a specific timer for that. So we have this new thing called finished span handler, and what does that do? It handles data that you get when you finish a span. And one of the examples is to schlep some of that data to micrometer so that you can sort of like capture more metrics from anything that you've traced. Other reasons for that are things like redaction. So for example, you may find that you have social security numbers or PII data, and people are have them in their HTTP requests, right? Like it might. So this finished span handler and other use of that is to allow you to do data cleansing before it exits the process. Other things may be a little bit more science fiction in nature, but like if you can imagine, if you can aggregate metrics, then you can do interesting things like adaptive sampling, meaning that I want to get more samples of things that take too long. So maybe I have my probability set to this much, but then I want all HTTP requests that are starting to take 2 seconds to always have a trace. So there's some really fancy stuff there. And then I guess one of the other fancy things is like some sites like Yelp, they have like a customer support story where they always want to have 100% of traces, but it's too expensive. Like I remember going to Netflix once and they said that if they had 100% of traces, it would cost more than playing the movies. So you don't want to be in that situation. So there's some things that will be labeled with the word firehose, which will discuss features that where you're getting 100% of data, and usually there's some fine tuning in how that works, such that it can be not cheap, but not expensive at the same time. And here we go, question time.
Any questions? So the question was, how do we add baggage to the context that we use Span Customizer? So to add baggage, essentially you have to whitelist the tags, and you provide the extra propagations, as far as I remember, right?
There's a thing called literally extra field propagation, which allows you to add extra fields to propagation. but basically, if you have to have a whitelist, because we learned that like people would add baggage that would like crash the requests, and so usually with that in place, then if you want to add something that wasn't already given to you upstream, then there's an API to do that.
But do you have to manually add it to MDC later?
Well,
So the question was, do you have to manually add it to MDC later? So with the version 2.1 of Sleuth, we've added whitelisting of keys for MDC. So you have to just provide it as a property, and it's there in the MDC.
Exactly.
Oh, the question is to you.
Open Tracing API has less features than we need to do our job, so we can't do that. But we do have a bridge which would allow people who are using it for certain functionality to use that API. That's existed for, I think, at least a year now, and I work on that all the time, to my chagrin. So yeah, you can use Open Tracing if you need that, and also bear in mind that one of the things with this finished span handler is that you can have a raw feed, and one of the use cases that we support with that is sending data anywhere, not just metrics, but anything that can receive data. So one of the use cases is actually sending to multiple tracing systems.
So one of the things that, let's say, happened thanks to Brave is that Sleuth right now, via Brave and the bridge, Sleuth is Open Tracing compatible. Any questions? Oh, there you go.
Is there any control over the trace ID and span ID generation? Like, is there a factory for that, or is it always just a SHA, or what is it?
Yeah, so we currently don't have a way to control it. Sorry, the question was, can you change the shape or maybe the algorithm used to generate IDs? Right now, it's fully random because some of the sampling algorithms require it to be random to work, and it's basically defined in this thing B3, which would be either 64-bit or 128-bit, 8-bit, like 16 or 32 characters of hex, and the span ID is always 64-bit. But yeah, there's no current way to change that. But some are able to pre-provision IDs. So for example, we have the ability for you to preordain like the trace ID. So you can control that, but you can't control the span ID generation at all.
I think we're done. So we have to take the questions offline.
Yeah, we'll be here, so we can.
Okay. Thank you very much.
Thank you.